Look at these values on your screen. These are special angles, trigonometric ratios. In this video, that's what I'm going to be proving. Let's begin. The two angles we are considering is the angle 30 and the angle 60. An equilateral triangle. Equilateral, it means it has equal sides, equal angles. Equilateral triangle of 60 degree. Let me make it bigger. 60 degrees. 60, 60, 60. Now let's since it has equal sides, we can actually pick 10, 10, 10. 10 is actually not bad, but to make our work easier, let's pick 2 instead. Any digit would work. We can make this equilateral triangle and a right angle triangle by what? By dividing it into 2. So if this is divided into 2, we have this. Let's pick 1/2. The angle at the top is also divided into 2, so we have a 30 here, an angle of 30 degrees here, 30 degrees, and we have 90 degrees here since it's a perpendicular bisection. So we have from 90 degree here, and here we still have our 60 degrees. Here we have 2. Here we have, since it's divided into 2, we have 1 here, so we have to get this side, and to get this side we use our Pythagorean theorem. The square of the largest side is equal to the addition of the square of the other 2 sides. So the largest side here is 2, so 2 squared is equal to 1 squared plus, let's assume this x squared, 4 equal to 1 plus x squared. So we have x squared equal to 4 minus 1, which equal to 3. Since we are looking for x, we take the square root of 3. So we have x is equal to the root of 3. So we can erase this now. Now we have the root of 3. Now you see that it's actually very easy to have the values, the values of those trigonometric ratios. We know that cos theta is equal to the adjacent side of the angle over the hypotenuse. Sin theta is equal to the opposite side over the hypotenuse side, and tan theta is equal to opposite side over adjacent side. You can actually combine this in so ka twa. So whichever way you pronounce it, it makes it very easy to remember. So we have so ka twa, sine of an angle is equal to opposite over the hypotenuse. The cosine of an angle is equal to the adjacent over the hypotenuse, and the tangent of an angle is equal to the opposite over the adjacent. So in this right angle triangle, which side is opposite, which side is adjacent, and which side is opposite? I hope I've not said that before. So let's draw our right angle triangle. We have our right angle here. Let's take the angles here. Supposedly, as we've been taught in school, the longest side is the hypotenuse. So wherever the angle faces is the opposite. So if we are considering this angle, this would be our opposite side, and this would be the adjacent side. If we consider this angle, this would be our opposite side, and this would be our adjacent side. So it actually depends on the angle, and this here, the hypotenuse side, is always constant. So now let's take this out. So let's take the angle 60, the special angle 60. So the sine of angle 60 would be opposite over hypotenuse. So since we are considering angle 60 faces here, so this would be our opposite. So we have root 3 over our hypotenuse, which is 2. So this is sine 60, cos the cosine of 60, cos 60 would be adjacent over hypotenuse. So we would have adjacent as 1 over 2. And we have tan 60 is equal to tan 60 is equal to opposite over adjacent. Our opposite is root 3 and our adjacent is 1. This is equal to root 3. So these are the values for sine 60, cos 60 and tan 60. Let's take sine 30. Sine 30 is equal to, this is the angle we are considering, sine 30. This would be the opposite. So this is 1 over our hypotenuse 2. Cos 30 would be adjacent over hypotenuse. This would be our adjacent now. So we have root 3 over 2. And our tan 30 would be opposite over adjacent. Our opposite over adjacent would be 1 over root 3. By rationalization, this would be root 3 over 3. So these are the trigonometric ratios for these special angles. I hope you learned something from this video. Don't forget to subscribe, give me a like. Thanks for watching. I hope I will see you in other videos. Bye.